High-voltage bushing is an important transformer component that ensures its reliable, fault-free and endurable operation. Internal insulation is a key construction part of a high-voltage bushing that defines its technical and operational features. Presently, the most advanced type of internal insulation is a solid RIP insulation. Bushings with this type of insulation are highly reliable and more durable thanks to low dielectric loss and partial discharge level in the insulation, its thermal resistance. Izolyator has successfully developed RIP bushings of up to 800 kV voltages for 15 years. Mass use of RIP bushings in Russia and power industry of other countries shows that the most important stage for a sound bushing operation is its installation in a transformer. Due to RIP insulation design features, this operation has substantial differences from analogs and requires careful study and full compliance with the manufacturer's instructions. This is a video instruction on Izolyator RIP bushings installation. The film details a 500 kV bushing bottom terminal connection and a 220 kV draw LED transformer bushing installation process. Bushings with oil-filled porcelain external insulation are used as demonstration samples. Bushings with other types of external insulation are installed similarly. Contents: RIP bushing design, slinging a bushing packaging, unpacking and removing the bushing, examining the bushing's exterior, setting the bushing to a vertical position on a stand, checking internal insulation of the bushing, getting ready for installation, bottom terminal bushing installation, draw-LED type bushing installation, conclusion. RIP bushing design. An RIP insulated bushing consists of the following main elements: the solid insulation core made by insulating paper winding on a central tube with subsequent epoxy compound impregnation. RIP insulation is such. The paper winding layers are separated with conductive layers or insertions for leveling up electric field. Central flange mounted on the insulation core. Test tab kept in electric contact with grounded insulating layer. Mounting flange for the bushing installation in a transformer. The flange has eyebolts and a plugged air release hole for air outlet from the transformer. The hole can later be used for bleeding hose connection. Topside porcelain external housing with transformer oil or dry filling. In case of oil filling option, a body with clear view oil glass is used. There can also be used a polymer external insulation. Tightening spring unit at the top side of the bushings. Bottom corona shield, intended for equalizing the electric field in lower part of the bushing. Contact terminal for the bushing connection to a transformer lead. There is a corrosion-proof nameplate on the coupling of the bushing. It contains maker's trademark, drawing number, type of bushing, bushing weight, serial number, date of manufacture, state technical standard number. Take a look at this nameplate example here. Mark that the unique serial number is fulfilled by impact. So with all other data possibly lost, one can easily restore all required information on the bushing, starting with the date of manufacture and ending with the acceptance tests results at the factory. Slinging a bushing packaging. Let us proceed to the installation of a high-voltage bushing, which starts with the loading-unloading operation. Before you start unpacking a bushing, make sure that the facility has operating means of communication, the unloading machinery can carry the weight of the product and is in good order. Cargo wire ropes meet necessary characteristics, are certified and intact. Packaging and bushing slinging and hauling must be done by individuals having necessary health and safety certification. Slinging of a bushing packaging. must be done according to the markings on the side of the box. To tie up the packaging, pass the cargo rope under the bottom of the box and set it on the hook from one side and then from the other. Lift the box from the floor slightly and make sure it is balanced. Only then any holding of the package can be done. Take off the cover and screwing self-tapping screws that fix it to the side boards. Depending on the bushing's dimensions, the cover can be made of a single or several plywood sheets and can be used for packing the bushing up later again. So with that in mind, we recommend to keep the screws in a designated place. Check for supporting documentation, which should be attached to the packaging side. It includes Certificate of Conformity, Maintenance Manual, Packing List. Please verify the completeness of the bushing set against the packing list. Study the bushing maintenance manual. It contains all main operations including removal from the packaging, installation in a transformer, and operational maintenance. The plant warrants that only with the manual requirements fulfillment a high-voltage bushing will operate reliably and fault-free throughout its entire service life. Study carefully the slinging scheme of the bushing, removal from the package, and setting it to an erect position. Thus we have completed slinging operation. So let's repeat the key steps. Make sure the supporting documentation is in place, study the maintenance manual, study the slinging scheme of the bushing, sling in accordance with the markings on the packaging. Removing and unpacking a bushing. Take off polystyrene pads from the top side of the bushing, placing them next to the package on a flat surface. You will use them to put the bushing in a horizontal position. Cut the ties on the bushing inside the package. Tie up the bushing at the handles on the coupling. Those may be lugs or eyebolts of required carrying capacity. The top side of the bushing must be tied between the second and the fifth sheds of the housing. In order to avoid damage of the porcelain housing, use soft toes. Smoothly lift the bushing above the package to minimum height and make sure it is level. If slanted, put it back in and tie it up using other sheds. Only after it's done, you can remove the bushing and perform further operations. Put down the bushing with the porcelain housing resting on the polystyrene pads that you prepared. When setting the bushing to its horizontal position, try to make it rest on the same areas as inside the packaging. Unbolt and remove the shipping cover from the bottom side of the bushing, which is attached to the central flange. The cover is used to prevent the bottom side from any mechanical damage when shipping and storing. To avoid any damage to the bottom side of the bushings, use at least 2 men to remove the cover. Also remove polyethylene cover from the bottom side and silica gel bags used for protection against humidity. Thus we have had a look at the bushing removal and unpacking. Let us now go through the key steps again. Tie up a bushing at the handles. Tie up the top side of the bushing between the second and the fifth sheds of the housing. Remove the shipping cover using 2 men. Examining the bushing's exterior. Examine the bushing closely for any porcelain housing and bottom side damages. Pay special attention to any housing cleavages. None should be found, as they can develop later and fully destroy the housing, leading to the bushing failure. There mustn't be any oil leakages or damages on the parts of the bushing. There can be a small amount of oil found in the bottom side of the bushing, and especially inside the tube of the draw-lead type bushing, after the tests at the manufacturing plant. This is not an oil leakage indicator. If necessary, take measurements of the bushing unit's geometrical dimensions, though it is an optional procedure. A bushing goes through a multi-stage control in production, and the manufacturer guarantees its conformity with quality management regulations. Use a cleaning cloth with anhydrous solvent and wipe the bottom side of the bushing with a mounting flange. This procedure is to be done before the internal insulation properties check in order to receive reliable measurements. Thus, we have examined the bushing. So let us review the most important points. Examine the bushing for any damages of the porcelain housing and bottom side. Clean the bottom side of the bushing and the mounting flange. Setting the bushing to a vertical position on a rack. Set the bushing to an erect position. This is a particularly demanding operation, as there is a danger of the bottom side damage. However, it can be avoided if you follow certain rules. Pass 2 soft toes along the porcelain housing to the coupling. Bind the toes with an additional one under the second, 5th large edge of the porcelain housing. Fix the toes on the coupling handles, can be lugs or eyebolts. Stretch the toes along the housing and fix them with another toe to eliminate slipping. If necessary, use an additional toe for fixing. Lay a suitable soft material, rubber or felt, under the bottom side of the bushing. Please note that the lower shield is not to be installed at this instance because it could be damaged with a high probability. Avoiding the bottom slipping, steadily turn the bushing upright and set it on a temporary rack. We have talked about setting of the bushing to a vertical position on a stand. Now let's go through the key points again. Pass 2 soft toes along the porcelain housing to the coupling. Bind the toes with an additional one under the second, 5th large edge of the porcelain housing. Fix the toes at the coupling handles. Stretch the toes along the housing and fix them. Place a suitable soft material under the bottom side of the bushing. Turn the bushing upright and set it on a temporary rack. Checking the internal insulation condition of the bushing. Perform the measurements on the bushing. It is imperative to adhere to the requirements of the power system safety standard, while taking electrical measurements in order to evaluate the technical condition of a bushing. There are several stages to complete measuring of the internal insulation condition in a high-voltage bushing. The first step. Take a measurement of the test tap insulation condition. The surface of the test tap insulation should be clean and dry. Use a 2500 volt megometer to measure resistance on the test tap insulation. The resistance value must have a finite quality, circuit continuity, and be not less than 1000 megohms operational commissioning and not less than 500 megohms during operation. The second step. Capacitance measurement and dielectric loss angle tangent measurement on the main insulation of the bushing. Attention! Capacitance measurement and dielectric loss angle tangent measurement must not be done between the last plate and the coupling, because the applied voltage can cause electrical damage of the test tap unit. Bushing checks require a certain experience with tools, measurements and configuration, and results interpretation. Partially, it depends on the fact that capacitance values are relatively small and can be distorted even by spatial factors of the ambient, including a bushing's position inside a transformer, that can influence measurement value after installation. Humidity, weather conditions and other factors also influence dielectric loss tangent measurement results. Correct measurements and results evaluation allow for a quality bushing operation throughout its operation life. Based on years of RIP bushings production experience and field operation data, we can say that a minute increase, less than 2/10, of the dielectric loss tangent against values shown at the acceptance tests at the manufacturing plant is not a symptom of damaged insulation. However, should there be need to receive the main insulation's dielectric loss tangent measurement result approaching the one received at the plant, and the newly obtained results are higher, additional manipulations like the bushing's bottom side drying with a hot air blower and wiping with alcohol or anhydrous solvent are required. A thermal vacuum chamber of suitable size can also be used. Marginal acceptance growth of the main insulation makes 5% of the value received at operation commissioning of the bushing. The capacitance and loss angle tangent measurement values received at the acceptance tests are stated in the certificate of equipment. Let us now turn to an important process of the proper test tap grounding. The grounding is done with the help of a special-purpose multi-contact attached to the hood of the test tap with a wire. The function of the hood is sealing of the test tap cavity and protection from mechanical damage, whereas the wire will not allow losing the grounding multi-contact. In order to unground the test tap, it is required to unscrew the hood and take off the multi-contact from the pin of the test tap. It will ensure the test tap ungrounding and possibility of internal insulation condition measurements. After the measurements are performed, the bushing must be grounded. Otherwise, should a high-voltage bushing be energized, the ungrounded pin of the test tap would receive approximately 50% of the voltage applied to the contact terminal, and that would invariably damage the test tap soon, leading to the complete breakdown of the high-voltage bushing. In order to ground the test tap, the multi-contact should be inserted so that the central hole of the lead went on the pin and the spring-loaded contact matched against the hole in the test tap body. At this moment, visual and tool control of the grounding reliability is possible, although with the proper installation of the multi-contact there is no need in the operation. Afterwards, it is required to screw on the hood of the test tap by hand by pressing on the rubber O-ring on the test tap body. The quick but demanding operation of the test tap grounding allows for eliminating one of the main causes of high-voltage bushing's damage. Thus we have checked the condition of the internal insulation of the bushing. Let's repeat the key steps. Use a 2500 volt megometer to measure resistance of the insulation. The value of the insulation resistance must not be less than 1000 megohms at the bushing's operation commissioning and not less than 500 megohms during its operation. Do not perform measurement of capacitance and dielectric loss angle tangent measurement between the last plate and the coupling. Always ground and seal the test tap after measurement performance. Getting ready for installation. After all required measurements are done and on condition of the bushing conformity with the product certificate data, we can start installation of the bushing in a transformer. Prepare the mounting seat in the transformer. Make sure there is a seal in place and check it, making a replacement one if necessary. The installation process of bottom terminal bushings differs from that of a draw-lead type bushing. Hence, we're describing them separately here. Set the lower shield onto the transformer tap. If the shield comes with paper insulation, it is supplied inside a special oil tank. In that case, undo the tank lead bolting and accurately remove the shield, which is attached to the lead. Next, take off the shield from the lead and insert it in the transformer, passing flexible tap wires through the central hole. Thus we have prepared for installation. So let us repeat the most important steps. Prepare the mounting seat in the transformer, make sure there is a seal in place and check it. Bottom terminal bushing installation. Accurately bring the bushing towards the transformer and carefully align it against the transformer adapter. Align the flange holes with transformer trunk bolts and ease the bushing into position. The mounting flange bolts should be tightened circumferentially, avoiding separate fasteners wrench off. Fix flexible tap connectors at the bottom tip of the bushing and the transformer tap. The shield at this moment is lower and does not affect operation. Tighten all fasteners thoroughly to avoid their unscrewing during operation. Special measures must be taken to eliminate risks of tools falling inside the transformer. The simplest method is binding tools to your hand with a suitable material. After flexible connectors are installed, place the shield in its proper location by putting the lower shield on the contact tip so that the bolt heads align with the wider area of the slots in the shield. Press on the shield circumferentially and rotate it to make the bolts enter the slots all the way in. Loosen the effort and make sure the bolt heads are firmly settled in the end positions of the bolts. Make sure that the shield is firmly attached in its position and no uninsulated transformer tap connectors are showing. At this stage, we can consider the bottom terminal bushing installation complete. Thus, we have reviewed the bottom terminal bushing installation. Let's repeat the key points. Accurately tighten all fastening elements. Make sure the shield is firmly attached after installation. Check for any parts of uninsulated transformer tap connector showing from under the shield. Draw lead type bushing installation. There are no critical differences in a draw lead type bushing slinging removal from packaging, setting on a temporary rack and measurement of internal insulation condition from the same operations on a bottom terminal bushing that we have just detailed. Therefore, we will simply illustrate them with the following frames. Let us study an operation which is not present in the bottom terminal bushing installation works, namely removing the brass cap from the top side of the bushing, which requires unscrewing 8 hex socket head bolts. This operation can be performed either on the horizontally or vertically positioned bushing after its lifting onto the temporary rack, either before removing the protective cover from the bottom side of the bushing or after that operation. If the bottom side length and dimensions allow, the cover can be removed by one technician. Remember to clean the bottom side of the bushing and the mounting flange exactly as with the bottom terminal bushings. Likewise, do not forget to examine the bushing for possible damages and oil leakages. The setting of the bushing to a vertical position does not differ from the process described for the bottom terminal bushing either. However, for draw lead type bushings, there is an extra operation to be done. It is required to pass the toe with attached eye bolt through the central tube of the bushing. The toe will be later used for drawing through the contact pin with soldered-in transformer tap lead. After the bushing is set to a vertical position, put on the lower shield. It is fixed by a special split nut, which should be screwed tight on the thread segment of the tube until stop at the shield. The nut should be then fixed with a supplied bolt to avoid unscrewing. Upon completion of those operations, one can proceed to the bushing installation in a transformer. Lower the toe with the attached eye bolt and screw it in the hole of the preliminary solder to the transformer tap lead contact pin. Put the contact pin inside the central tube of the bushing and hold the loose end of the tap lead in. Now carefully ease the bushing on its position, simultaneously drawing the tap lead through the central tube. Control the lead entrance to the tube through the transformer access cover. Make sure that the uninsulated parts of the tap leads are not showing from under the lower shield. And then do the final tightening of the bushing in the transformer. The contact pin mounting is a particularly demanding operation, because it may lead to loss of air tightness by the bushing if done wrong. Draw the pin with the tap lead in such a way so that you could insert a retainer pin in its side hole. Fix the pin inside the tube slots. Detach the eye bolt with the toe as they are no longer needed. Install a spring washer on the end face of the contact pin to ensure reliable electrical contact. Screw the brass cap onto the contact pin. Note, you must keep screwing the cap even after it touches the O-ring. If you bolt the cap to the bushing flange at this moment, later with the temperature change, the top side cap of the bushing will move by 2 or 3 mm, leading to a loss of air tightness. Therefore, continue screwing the cap on and tighten it with a tightening torque key of no less than 100 Nm. Align the nearest mounting holes in the cap and the flange and fix the cap with screw and washer assemblies. Set the contact terminal on the contact pin of the bushing. This operation is identical for all bushing types of any complexity. Thus, we have considered the draw lead type bushing installation. Let us review the key points. Mount the lower shield, which is fixed with a special split nut. Put the contact pin inside the central tube of the bushing and hold the loose end of the tap lead in. Screw the brass cap onto the contact pin. After the cap touches the O-ring, you must keep screwing the cap on. Tighten the cap with a torque key of not less than 100 Nm. Set the contact terminal on the contact pin. Conclusion: the correct installation and measurements provide a solid basis for a bushing's fault-free operation over many years. That is why it is important to pay your utmost attention to following the instructions detailed in this video. Please contact Izolyator plant with any questions on bushings installation and operation.